Hi. Here we solve a graphical statics problem, which is very easy to do since we won't be using tedious and lengthy calculations. The problem concerns a truck tipper in the unloading position at the very beginning of the operation. This tipper is hinged to the chassis at point A and lifted by a hydraulic cylinder at point E. Its weight is 18,000 newtons. Everything is illustrated below by a figure showing the position under study and a video sequence showing the unloading operation. After determining the three forces acting on the bed, we then determine the two forces acting on the hydraulic cylinder. The data needed to solve the graphical statics problem are as follows. The tipper body is connected to the hydraulic cylinder at point E and to the chassis at point A. The hydraulic cylinder is hinged at point O, the origin of the coordinate system are O, X, Y, Z. Note that all joints are considered perfect and frictionless. I still recommend you look at the illustration opposite to fully understand the rest of the solution. Let's now move on to the expected graphical solution. To begin, we draw the directions of the three forces acting on the tipper, which must meet at a point of intersection I. First, the weight, then the reaction force of the hydraulic cylinder, and finally the reaction force of the chassis. These directions are used to construct the closed polygon diagram. Since the scale is fixed beforehand, we can easily determine the magnitudes of the unknown forces. The closed polygon is a vector summation graph that represents the sum of the external forces acting on the tipper, which is 0, for the tipper to be in equilibrium. Converting centimeters to newtons, we find the reaction force of the hydraulic cylinder is 4,000 newtons and that of the chassis is 15,000 newtons. Now, we will represent the force vectors determined on the figure of the truck in the position of dumping the contents of the tipper. If you are using paper drawing, you only have to slide the vectors considered parallel to each other as shown in the animated illustration. So, to balance the cylinder, we proceed in the same way, except that here, the cylinder is subjected to two forces having the same magnitude and opposite direction. This is the principle of action and reaction. Thus, at each end of the cylinder, we represent two forces. At joint E, the action of the tipper body on the cylinder and the opposite reaction, and similarly for the action and reaction of the chassis and the cylinder at joint O. These force vectors are drawn to scale, thus, their intensities, which are obviously equal and have a value of 4,000 newtons, can easily be determined. Finally, we transfer the force vectors considered onto the truck diagram, and as you will see, only the forces acting on the hydraulic cylinder are represented in the illustration. I hope you enjoyed the exercise, and see you in another theoretical mechanics video.